Hello friends, today we will be looking at different machine learning models and how do they perform on the dataset beer consumption, in which we have to predict how much beer is consumed given certain features. This dataset is based on Sao Paulo, which is a municipality in Brazil. So this is the dataset which we can take from Kaggle. Let's have a look how we have implemented different machine learning models on this dataset. First, we import the necessary libraries in the first step. Let's run this. And after this, we read the dataset, which is named as consumer underscore surveja. Here you can see there are 7 columns named as data. This is not data, actually this is date. Temperature media, temperature minima, temperature maxima, precipitate cow, final decimina, consumer the. This is called liters. The values here in every row is not a numerical value. It is like 27 comma 3, and which it should have been 27.3. So we replace all these comma with decimals. In the next step, here we can see the structure of our dataset with openfiles.info. Let's run this. So before this previous step, I was talking that we replace all the commas with full stops, basically to convert them into numerical values. So in this step, we are doing that. And actually our dataset also contains date. So we are splitting the date column in different other columns, like here we can see year, month and day. So we are splitting the date column in year, month and day. So let's run this. And when we see our dataset now, uh, there are multiple different columns, year, month, day. And so now we don't require the date column, so we drop it. Now we have to look at the missing data. How much missing data does our dataset contains? So in this step, we see more than 50% of the dataset contains missing values NaN. So it's of no use. So we drop them all. Here we drop all the missing values which have NaN. And also we are normalizing with min max. What min max does, it takes the maximum value as 1 and normalize all the other values compared to that maximum value. So when we run this, we see our dataset has been normalized and all the values have come between 0 to 1. Now we split our dataset into X train, Y, X test, Y train, Y test. From the next step onwards, we will be looking at different machine learning algorithm. The first one we will be looking at will be linear regression. So we do this, and we fit our X test. This is our Y pred. We fit our X train and Y train to our linear regression model, and we see different matrix values. We see mean squared, mean absolute, R2, median absolute, accuracy. We are doing this step for all the machine learning models we'll be looking at. So here you can see different values for this. In the end, we will be comparing the R2 score of all the machine learning models, and the R2 score, the closest to 1, will be the best model in our case. Here we can visualize the data set, not the data set, the linear regression model. This is between actual and predicted. You can see the graph. Now we look at ridge regularization. Ridge regularization is basically based on L2 regularization. Here we do the same as linear regression, but in this case we take alpha, the learning rate, to be 0.01, and we print all the matrix values. And similarly we plot the graph. Now we take alpha to be 100, which is more than the previous one. Previous one was 0.01, and you can see the R2 score of this when alpha is 0.01 is 0.74, and when we take alpha to be 100, the R2 score reduces significantly and changes to 0.26. So what it shows is that if we increase the alpha value, the R2 score decreases. Where you can see the plot. Now the lasso regularization, which is based on L1 regularization. Firstly, we take alpha to be 0.01 and we note down R2 score as 0.59. We plot the graph. Then we take alpha to be 0.001, 0.0001 actually, which is less than the previous one, and the R2 score increases. So from till now we have seen that minimum the alpha value, the better will be our model, the better it will fit. Now let's look at polynomial regression. The same thing for polynomial regression, and we can see the R2 score till now for polynomial regression is the maximum, which is closest to 1, which is 0.94. You can also see the plot, it's actually pretty close. Now let's look at the card decision tree. Firstly, we have taken 15 and 7 as maximum leaf nodes and minimum samples leaf respectively, and we notice R2 score as 0.62. And then we have changed the maximum leaf nodes and minimum samples leaf to 16 and 10, and we note down the R2 score as 0.62589, and the previous one was 0.62875. So yeah, the second one is slightly better. Also we can see the graph here. Nextly we see random forest. R2 score for random forest is 0.62, still lower than the polynomial regression. And lastly we see the neural network. R2 score of which is negative, means it is badly fit. You can also see the plot, all the predicted values are similar, the actual are different. So what we have seen is that the polynomial regression fits the best on our data set and gives an R2 score of 0.9495, which is the best model in our case. Also, I have written an article on this on medium.com, prediction of beer consumption in Sao Paulo with different machine learning models. Processing, normalization. Have a look at this article, the link will be down in the description, and let me know your responses on this article down in the discussion section here. Thank you and happy hunting.